Hey, I'm Evan, Head of Engineering for RMSTATOR. Today we're going to do a video showing you what are the different ignition, charging, electrical, and starting system components on your motorcycle or ATV or side-by-side, watercraft, snowmobile, you name it. All these Powersports type of vehicles have these components in common with each other. Now there's lots of little variations, but we're going to go over the main components that are used in these systems and give you a general overview of what they do and why you need them. So the first part we're going to talk about is the stator. This is the heart of the charging system on your vehicle and the ignition system on some models. They come in a lot of different sizes, but they're all generally the same type of part. I'm going to show you some different examples here. And some of them have other components attached to them. Some of them have longer wiring harnesses to make other connections. We'll get into the specifics later. You'll see some of them are mounted on a backing plate here, and others are not. Some of them have completely separate coils on them to do different functions, some don't. So the other major piece of your charging system is the voltage regulator rectifier unit. These also come in different shapes and sizes, but have the kind of the same general layout for most fitments. You'll see some have the wiring harness attached, some just have connectors that are built in. You can see they have different shapes and different for different mounting locations. There's a lot of different sizes depending on the vehicle and its use and the power of its electrical system. There's small regulators that are not rectifiers but are used to protect lighting systems, specifically on dirt bikes and ATVs a lot of the time. Another important component of the charging and ignition system is your flywheel. This is what helps generate power from the stator and what's actually spinning in your motor. So here's two examples of them. This is an RMSTATOR flywheel here, and this is an original flywheel. Here's a different type of flywheel. So they come in lots of different shapes and sizes. Another important component is the pickup coil. This is part of your ignition system. You might have noticed that this is part of the stator assembly with a lot of stators. We also build them and sell them separately if that's the only part you need to replace. And we have our starter relays. These are the guys responsible for sending power to your starter motor to actually turn your engine over. And we have CDI boxes. This is the heart of your ignition system that on an electrical ignition system for Powersports basically calculates your ignition timing and tells your ignition when to fire. You can see they come in different shapes, sizes, plug configurations. And then we're also going to talk about ignition coils, and they also come in different configurations. Some plug directly onto the spark plug like these guys. They're called cap coils. Some have a spark plug wire and a cap separately, or not separately, but attached to the coil itself. And some fire two spark plugs from one coil, some fire one. Lots of different configurations for these, but they all do basically the same thing. So now that you've seen the different types of parts we're going to talk about, let's dive into them specifically. Okay, so let's talk about stators in detail. What are they and what do they do? So on most bikes, they're the heart of your battery charging system, and on some, the ignition system as well. A stator is pretty simple. Now, I showed you there's a lot of different configurations and sizes for them, but they all do the same thing. A stator is an iron core, round, and it's made up of what are called laminations. And basically, if you took the shape of this, each arm on this stator is called a pole. If you took this and you sliced it into a bunch of flat layers, each one of those is a lamination. Now you probably can't tell from looking at it, but if you look really close, you can actually see the ridges on the end and see that it's actually made up of a bunch of flat plates. So they're stamped out almost like a cookie cutter. And then they're stacked on top of each other and riveted together. You can see the rivets here where the plates are, the laminations are all stuck together. So that iron core then has some sort of protective coating on it to protect your windings. Then you have your copper wire that is wound around each pole of the stator. So these make up, these coils make up your either charging, or they can also be used to power ignition or lighting or other things. They make up your power generation system. And I'll show you some of the different configurations of these stators. You also can see that most stators will have a wiring harness attached, and they'll have what's called a grommet here, which are these rubber pieces. These are meant to fit a cutout in the case of the motor where they mount, and this lets the wire exit the motor and seal it up so oil can't get out. And then they'll generally have your plug on the end to plug into the wiring harness or to your voltage regulator. So let me show you some different configurations, and we'll talk a little more about how they work. So actually, to focus on this guy a little more, this is very typical. This is what's called a three-phase stator. It's all used for battery charging, and it's actually 3 separate coils wrapped around this core. Every third pole of this stator is 1 coil, and they're all chained together, and that's why you have 3 wires running out for the 3 separate coils. So there's lots of different sizes and variations of this, but this is very typical for a motorcycle or an ATV that just needs to charge a battery. So here you can see, actually let me show you this guy. This is basically the same thing, a lot different shape, or different size, different dimensions, you can tell. Still made up of separate laminations riveted together just like the other one. It's obviously a lot larger and thinner. This is what's called a single phase stator. And you can tell it only has 2 wires coming out of it. Well, that's because this is actually 1 coil wrapped all the way around. It does not have multiple coils that alternate like the other one I showed you. And I don't want to go into too much detail, but the way that they are wound, either with 1 coil or with multiple coils, depends on the type of system and how much power you need and where in the RPM range you need that power. So there's a lot of specifics that go into coming up with the right design for one of these based on the needs of the vehicle. So let me set this out of the way. Now here's another one, similar to the first one I showed you. This is a 3-phase stator, so it's made up of 3 separate coils wrapped all the way around. If you look, you can see 3 yellow wires exiting, which are those 3 coils. And then you'll see that it has something else attached to it. Well, this is called a pickup coil, or a pulsar coil, or trigger coil, crank position sensor sometimes. And we'll talk about those in detail a little more later. But a lot of times these are attached to the stator harness because they are mounted right next to the stator. So it's a lot easier to make this all one assembly and run the wires together, sharing the same rubber grommet. Other than that, it's very similar. You see it has wiring harness coming out, and it has its connectors on the end. Stator like this has these yellow wires is typically your stator connection for battery charging, and you have that plug here. And then this one you have a separate plug for your pulsar coil for your ignition system. And this actually has a separate coil wound on it that you can't see, and I don't want to get too confusing, but it has what's called a position sensor coil that is for kickback prevention on big single cylinder motors. So we don't need to worry about that, but that's why that has an extra 2 wires in there. Remove that. So here's another type of stator. Again, looks similar, right? Different size and all than the others. Now, what you'll notice immediately looking at this is it has 2 poles on the stator that look different than all the others. So we can generally identify coils that are used for battery charging or lighting by being visibly bare copper. It's not actually bare, it has an insulation coating over it, but we can see the copper color. And fairly large gauge wire, so we can see how large these wires look. That's because this large wire generates a lot of current, but fairly low voltage. Well, we need a lot of current to charge a battery or run lights. So if you're looking at a stator and you see that copper looking wire, you know that that's probably used for a battery charging or a big light output, something like that. Now if you see a stator that has these different coils that look different than the others, a lot of times they're cloth wrapped like this, and they have kind of an epoxy coating that seals them. Well, these are called source coils. These coils are meant to power an ignition system directly from a stator. They're cloth wrapped and coated like this because we need to generate very high voltage but low current. So that requires very fine wire. So like we're talking hair thin wire. And that's why they're covered in a wrap like this with some epoxy coating to protect that wire. It's really vulnerable, to protect it from vibration or rubbing on anything. So that's what those guys are. This one also has a pickup coil for your ignition timing next to it, since that's mounted in the same place inside the motor. And just like the others, we have a rubber grommet to seal the case of the motor, and we have our connectors out at the end. Okay, so let's get this out of the way. Now here's one that looks different than all the others, but it does exactly the same thing. A lot of older vehicles and smaller motors still use this type of stator. This type of stator has a backing plate, which is this kind of bracket that everything's mounted to. It has a pickup or a pulsar coil as well that's mounted to it for ignition timing. And then you can tell that the coils look different than the others we were looking at. So these are called bar coils, and it's kind of the older way of doing it. It's used on smaller systems a lot because it's more compact. You can still see that you have some coils with kind of bare copper looking wire. Well, it's large gauge wire that's used for charging a battery or running a light. And then you can see that we have another coil that is cloth covered and epoxied. Well, we know that that's fine wire for an ignition system power output. So these look different, but they do the same thing. Each of these bars is made up of separate laminations, and you might be able to see it because these are large here. So they're all stacked together and riveted together, and then it has some sort of a plastic wrap or coating on the inside to protect it, and it has the wire wrapped around it. So that's some good examples of different types of stators. Next, we'll talk about flywheels to show you what goes along with these and how they generate power. In effect, we have magnets spinning past these, which induces electrical current inside these windings. So it lets us use the rotational power of the motor, which is going to be spinning anyways from the combustion going on. We might as well take advantage of that and spin some magnets past these coils and generate electricity. We can use that to charge a battery or run an ignition system or run lights or whatever we want. So that's a good overview of stators, and then we'll talk about the next subject. Okay, so here's a stator actually mounted on a motor. It'll give you a good idea of kind of where they're located and how they mount. So this is very similar to a Yamaha Banshee quad motor setup. You can see this stator has ignition coils, ignition source coils on it, like we were talking about, to power an ignition system. And then it has battery charging coils wrapped around the other part of it. We can see that it's mounted on a backing plate behind it that then attaches it to the motor. And then we can see that it has a pickup coil here for timing. And it's actually mounted against the case of the motor. So that gives you a good idea of how they mount and kind of where they're located. On a lot of motors, they'll have they can be mounted the opposite way. The stator can be mounted to the outside case, and then the case presses against this on the outside of the motor. This type has the stator actually mounted against the motor itself, and will still have a case covering it. On this particular motor, it's a dry case. There's not oil circulating here, but on a lot of engines, this is actually a sealed case and does have oil from the crankcase circulating around it, which helps maintain the stator temperature and keep it cool. So that's kind of a good example and good overview of how the stator mounts to the motor. All right, so let's talk about rotors, or flywheels as they're often called. So this is another key part of your charging and ignition system. These guys are a fairly heavy wheel that's mounted on the crankshaft of your motor. So what we're doing is taking advantage of the motor spinning anyways, and we mount these guys to the end of the crankshaft so they're spinning with it. Okay, and inside of these guys there's magnets arrayed all around the inside of this. So I can show you one here that doesn't have a cap inside, and you can see the magnets. So here's a flywheel that has visible magnets. You can see them mounted all the way around the inside diameter of the flywheel. You'll notice some of these have a ring on the outside. This is generally a starter drive ring that it meshes with your starter to turn the motor over. A lot of these use the same thing, they're just not attached to these flywheels. Okay, so we have these flywheels spinning with the motor. We know that. We know they have magnets inside of them. And what do? Well, the point of these is to spin around a stator. Now, obviously these aren't made for each other, but this is a good example. Your stator is called a stator because it's stationary, and you have your flywheel spinning around it. Well, these magnets induce electrical current in the windings of the stator and then give us electricity to charge a battery or run an ignition system or whatever else we need to do on the vehicle. So flywheels come in a lot of different shapes and sizes, various strengths of the magnets. You'll notice a lot of original OEM flywheels, this is for a Polaris Sportsman 500, I believe, have exposed magnets like this, which were kind of prone to breaking and failure because they weren't glued down very well. You'll notice a lot of the RMSTATOR flywheels, here's our version of this flywheel, have caps inside that seal the magnets. We also use better epoxy and better materials so the magnets don't come loose in the first place, but with a seal like this they're protected in case they ever do, so they can't hit your stator and damage things. So there's a lot of different shapes and sizes of these things. You'll notice if you look at the inside diameter of them, it might be hard to tell from the video, but they're actually tapered to a point, or to a, not necessarily a point, but they get smaller or larger depending on which way they mount. And that fits a matching taper on the end of the crankshaft. So the fact that you have these two angles that are the same and these are pressed onto each other gives you a good tight locking fit on the crankshaft so this can't come loose. The other thing you want to look at on flywheels is you'll notice on these guys they will usually have a slot on the inside, right? Like you can see right here. This one's probably a little more visible. So this is a slot for what's called a woodruff key. Your crankshaft will have a matching slot in it with a small key, a little half moon shaped key that sits in there, and that lines up with the slot on the flywheel when you attach the flywheel to the motor. Now what's important about that is it locates the flywheel in time or in sync with the motor, and that's important because the flywheel is often used for your timing system for electronic ignition systems. You'll notice that a lot of flywheels, hopefully you can see it here, have a ridge along the outside of it. This is called a reluctor, and this ridge is what basically generates a timing signal for your ignition system along with your pickup coil, which we'll talk a little later about how it works. But it's important to know what those guys are if you're ever wondering what these ridges on the outside of the flywheels are. You can see that there's lots of different shapes and sizes of them, but any of these flywheels made for use with an electronic ignition system will have some sort of timing mark on them. So that's the basics of the flywheel. We'll talk a little more about the ignition system so you get an overview of how it works together, but that's what these guys are and why you need them. And now we'll move on to another component. All right, and here we'll show you how the flywheel and the rotor mounts to the motor. So we see we have a stator behind it that's mounted to the crankcase here, and then here we have our flywheel rotor. So this type has the stator mounted on the inside, so the flywheel is going to sit over it from the outside. That means that you can see which way the taper's cut. It's bigger here on the inside and smaller on the outside to match the taper here on the crankshaft. And so here we can actually see the crankshaft where this guy sits. Now you probably can't see looking at it from that angle, but if we had the stator out of the way, you'd see that there's a little groove in the crankshaft with the what's called the woodruff key, the little kind of half moon shaped flat topped key that sits in there to locate the flywheel in place. So we can see our flywheel has timing marks on it. It has these ridges on the outside of it, and we can see that it has a slot on the inside that will locate itself on the woodruff key. Now I don't have the key in here, so it's not actually going to lock it up correctly, but I'm just going to kind of illustrate this. So if I slid my flywheel into place and I lined it up with the key, I slid it all the way in, well now my flywheel is lined up to the motor and it's locked into place in time, so these timing marks are going to be spinning in sync correctly with the rotation of the motor where the pistons are at. Well, the upside of that is we can use it for timing calculations because these marks will spin past our pickup coil here, which will provide a timing signal. So with that guy locked up, this guy will be spinning here on the crankshaft, and that'll provide our timing for our ignition system. The other thing is we can see how as I spin this, it kind of will want to stop in a particular place, right? Well, we can't see because it's covered, but that's because of the magnets arrayed inside the flywheel. The magnets are lined up, meant to coincide with the poles mounted around the stator, or part of the stator. So we can actually kind of illustrate that by seeing how the flywheel wants to stop at each rotation. Well, that's as each set of magnets lines up with the next pull on the stator. So even if we can't see them, we can kind of tell what they're doing and how they want to line up. So that's how a flywheel mounts. So there's lots of different kind of variations of this, but your flywheel will always mount to the crankshaft something like this and be secured with usually a washer and a nut that locks it in place and pulls it all the way in. Another thing to remember is these guys have to be removed with a special puller. You can't just pop these off. You have to have a tool that will safely press against the crankshaft and thread into the flywheel to pull it off safely without damaging the motor. So that's how your flywheel works. Okay, now we're going to talk about voltage regulators, or rectifiers as they're often called. So these guys are a very important part of your charging system, your battery charging system on your vehicle. Like we showed before, they come in a lot of shapes and sizes, but a regulator rectifier all does the same thing. The point of it is it does two functions. It does rectification and regulation. So the first part is the rectifier. Now your stator, I didn't really mention this before, but your stator is generating alternating current. That means that you have voltage coming from the stator if you know what a sine wave looks like, the voltage is going positive and negative as the two different polarities of the magnet pass the coils of the stator. So we want to charge a battery with that, but batteries only can accept current in one direction. So we need to get rid of basically the negative half of the current that's being generated from the stator. So we use a rectifier to do that. A rectifier is made up of a bunch of diodes, which are basically little electrical components that block electrical current in one direction and let it pass in the other direction. Well, that's perfect. It does exactly what we need here. It basically allows current to pass through that we want, the positive wave of the current coming from the stator, and it blocks current in the opposite direction. So we only have the current we need flowing towards the battery. The other part is regulation. So we need a regulator to protect the battery. The output of the stator increases with RPM. So you get much more current coming from your stator at 5,000 RPM than you do at 1,000 RPM. Because of that, we need something to protect the battery from overcharging. If the battery sat with the voltage too high for too long, it would easily damage the battery. So the regulation part of these works by, basically they're called shunt regulators. It works by shunting current to ground. So basically little switches inside these guys close using a circuit that controls them and directs that current to ground. And ground being the case, not necessarily the case, but the internal component in the regulator that lets it be dissipated as heat, which is exactly why you see cooling fins mounted all over these guys. They get hot in use and they need air coming past them to allow heat to be dissipated from the fins. So those are the two components of these. You'll see some called MOSFET regulators. That's the same thing. It's a shunt type regulator that basically dissipates unneeded current as heat, like I just talked about, but it uses a MOSFET transistor, which is a different type of electrical component, to do that shunting, to make the switch inside to bleed current off. That runs a lot cooler and it's a much more efficient switch, so it's just a nice upgrade and it's a better way of doing this. So you can see they come in a lot of different shapes and sizes. Some have wires built in, some have connectors built in, just depends. And some of them are made for the single phase, single coil stators like this guy, and some of them are made for the three-phase, three-wire stators like this guy. A lot of different configurations, but they all basically do the same thing. So the only other thing I want to talk about as far as regulators go is a different type of regulator, which is these guys. These are called AC regulators. Now they don't have a rectifier in them. They're not intended to be used with charging a battery. These guys are very simply to protect a headlight or some other component that's being powered directly off of the stator. So it doesn't prepare it for use with the battery, it just holds the voltage down when you're trying to run a light or something else right off the stator power. So that's an overview of how your regulators and regulator rectifiers work, and now we'll talk about a different part. So here we have CDI boxes. CDI boxes are the heart of your ignition system. So these guys basically take a couple inputs from your vehicle and then they give you one output, which is to drive your spark plug or drive your ignition coil, which will drive your spark plug. So these guys, they have, I'm trying not to go into too much detail here, but they have some electronics inside. They require power to run. Now they can be run on AC power, which if I show you a stator like this, has coils that are made specifically to power a CDI box. This is called an AC ignition system because it's powered an alternating current directly from a stator coil. And then some of these are called DC CDI boxes or DC ignitions because they're powered directly off the battery. They don't require a separate coil on the stator to be powered. Once they have their power source to run, they need a timing signal from your motor. From that they can calculate where the motor's at in its revolution and decide when to fire the spark plug appropriately. So I'm going to show you these other components we've talked about real quick just so you know what's going on. You'll have a pickup coil or a pulsar coil or trigger coil that is timed off the flywheel to create a pulse, okay, and that's fed into the CDI box. This guy creates its pulse by this ridge on the flywheel, which due to the Woodruff key here is locked to the crankshaft in a specific position, and this guy sits right here next to it and will create a pulse as the ridge on the flywheel first passes it and then the end passes it. It creates a positive then negative or negative then positive depending on the coil pulse. Well, if the CDI box, due to its electronics inside, knows the degree of this trigger, and it then can calculate from the pulse the pulsar coil's making, it can calculate basically where in rotation the motor is. The CDI box can then calculate using a timing map, knowing what RPM the motor's at. It can decide, okay, based on this RPM, I need to fire the spark plug at this time, advanced or retarded or whatever the map is set to. So it does that calculation inside to figure out when to correctly fire the plug based on input from the pickup coil, which of course is given from the flywheel. And then it'll have an output that goes to your ignition coil. That's the part that actually powers the ignition coil to fire the spark plug. And then they'll generally have a kill switch wire that's used to prevent spark or kill spark based on your key being turned off or your kill switch on the handlebars being turned off. And then different CDI boxes have different other functions. Some of them have an input from your neutral switch or your reverse switch if it's on an ATV, or maybe a clutch switch or a brake switch to allow it to only start in certain conditions, safety conditions, you know, if you're in neutral and your brake's on or your clutch is in, or the kickstand maybe. So it gives you a lot of different options depending on what the manufacturer designed it to do. So that's basically your CDI box. Like I said, they come in a lot of shapes and sizes. They mount different ways. Some of them have holes like this to mount with bolts. Some of them sit in a rubber, kind of a rubber sleeve to mount them to the frame. A lot of different types of connectors. Some have wires coming out, some just use connectors built in, but they all basically do the same thing. Your main difference is whether they're AC or DC powered, and then what other kinds of safety switch inputs they take. They are very specific to the vehicle, just like all these other parts, so they're not really interchangeable between makes and models. And anyways, that's a brief overview of your CDI box, and now we'll talk about another part. Okay, so here we have ignition coils. These generally come in two different types. We have cap coils, which are these guys. They're called cap coils because the coil itself literally plugs onto the spark plug like a cap. It sits right on top of it. These are usually used in newer dirt bikes and newer street bikes. Most older bikes use ignition coils like this that mount somewhere separate, usually to the frame somewhere. And then they have a spark plug wire coming out in a separate spark plug boot called the cap here. Now the coil is what's responsible for basically generating your spark. It is triggered from the CDI box. The CDI box means capacitor discharge ignition. So what's actually happening is a capacitor inside the CDI box is charging up, and when it decides the timing is correct, it'll discharge that capacitor. Well, that dumps a bunch of current out to the ignition coil. The ignition coil has two separate coils inside of it actually. One's called a primary and one's called a secondary. Now the primary is what the current from the CDI box flows through, and it's basically a transformer. The secondary coil then steps that voltage up much higher to a very high potential, and that's what then goes across the spark plug and creates the spark. You can see the ignition coils, they come in a lot of different shapes and sizes. They generally, well, they all will have some sort of a bar mounted through them that the coils are wrapped around. This will too, you just can't see it inside. And they'll have some sort of a plug or wiring harness attachment to take the output from the CDI box. And then, like I said, on these guys, you'll have your wire and your cap. This type will be mounted to the frame, and it's grounded, so it actually uses this mounting bar as one of the connections, so it only has one wire coming from the CDI box. And this is meant to just fire one spark plug, obviously, and only has one wire and one cap. So here's a dual spark plug coil. This one doesn't have caps attached, but it's the same kind of thing. It has a primary and a secondary inside. Primary takes your current from the CDI box, and the secondary steps it up to a very high voltage to create the spark. This one mounts as well with some sort of a bolt to the frame, so it's grounded. But it also has two wires coming in from the CDI box. One of these wires is grounded. And then this guy fires two plugs. So this type of coil can't fire the spark plugs at different times. It fires them together at the same time, but it can fire two. So this is used on a lot of different vehicles, not this particular one, but like a Yamaha Banshee will use a coil similar to this. And then same thing with these guys. They have the two wires coming in from the CDI, and they have a primary and a secondary inside. You just can't see it. And if I take the boot off, you can see the connection inside where it actually sits on the top of the spark plug. That's your electrical connection. So that's it for ignition coils. Now we'll talk about another part. So here we're going to talk about starter relays. Starter relays are important because the starter motor on your bike consumes a lot of power. It needs a lot of current from your battery. As you can imagine, that fairly small electric motor's got to turn over, sometimes a really big engine. And that's going to require a ton of power coming out of your battery. Well, we can't, we need to control that somehow, right? We only need to switch it on when we want the starter running. And we need a pretty beefy component to handle all that current and switch it on and off without destroying itself. So that's what we use a starter relay for. This guy, there's different shapes and sizes of them, obviously, but they all basically do the same thing. They'll have one or generally two wires that take your switch input. So this is on this type with two wires here. This takes the connection from your start button on the handlebar switch. So when your start button is pressed, it basically, one of these wires will be grounded. The other wire will get 12 volts coming from the handlebar switch when the start button's pushed. And when that happens, it actually closes, runs current through a coil inside that'll then close a switch. When that switch closes, it connects these guys, which these, there's a reason these are big screw type terminals. These are where your connection, one of these will have the battery voltage, the plus side of the battery coming to it, and the other side will go out to the starter itself. So you can imagine you got a lot of current flowing between these two terminals, which require a big connection. When the starter button is released, there's no more voltage here on the wire. That then disconnects the switch inside, and these guys go back to just being two totally separate terminals, not connected any longer. And that's what stops the starter from turning. So this type of starter relay does the exact same thing. You can see the large terminals, that the one will be the battery and one will be to the starter. And then you see on this type it actually has a fuse attached, and it has 4 pins here. Well, it still has 2 pins that control turning the relay on and off from your start button, but this type runs your master fuse for the bike's electrical system through the other 2 pins. So some of these, I believe this is for a Honda, but I might be wrong. They do this to save space, not have a separate fuse somewhere else. It's just built into the starter relay connector. So that's how these guys work. They're an important part of the system, and that's about it for these components. Now we'll look at something else. Okay, so we're going to give you an overview of how the whole system works together. Now that you've seen what all the different parts are and kind of have an idea what they do, let's look at how they all work together. So we'll start over here with the stator, and I kind of have these broken into the different general sections of the system: the charging system, the ignition system, and the starting system. I didn't include the lighting system here because we don't really deal with lighting parts, but the lighting system is generally run off the battery, so I'll just say that, not worry about it too much. So we'll start at the stator since we talked a lot about those. So your stator is right here, and I've illustrated, if it is meant to charge the battery, I've illustrated the charging coils here by these three guys. And you can see they all exit and run here over to our regulator. Okay, if the stator has a source coil on it, which was used to power an ignition system, I've drawn that right here. Okay, drawn around this in red, we have our flywheel. Okay, and I've got arrows to show it's spinning. And here I have the reluctor, or your trigger mark on the outside of the flywheel. And I also have the pulsar coil here that's generating a timing signal for the ignition system. So these are kind of all the guys that are mounted in the same place inside the cover of the engine. Okay, and your flywheel obviously is mounted and spinning with your crankshaft. Okay, so let's go down the charging system path first. So with most stators meant to charge a battery, now not all, some are single phase or a 2-wire stator that just has one single coil. But for most systems that are meant to charge a battery, they're 3-phase or have 3 coils and 3 wires exiting. So I drew that. So we'll pretend that our stator here just has charging coils on it, and those guys are coming out in these 3 wires, and they're running into our voltage regulator. So we're taking alternating current coming from our stator, and we're running it into our voltage regulator rectifier. Well, the first step of that, like we talked about, is the rectifier. The rectifier is cutting off the negative portion of the current that's being generated that we don't want to pass on to the battery. Then it's also acting as a regulator. So it is monitoring the battery voltage here and basically dumping current from the stator to ground when the battery voltage gets too high. And that's going to protect our battery from overcharging and from damage. Okay, so as all this is going, our battery's charging just fine through our stator and through our regulator. Then let's look over at the ignition side. So here I've drawn the CDI box. Okay, CDI box generally could have a lot more, but here's kind of the basic connections it might need. Your CDI box needs a power source to be able to do anything. Well, we talked about before, some stators have a source coil that powers the CDI box. That's drawn right here. We'll pretend the stator has one. That's called an AC CDI, or an AC ignition system, because it's powered from alternating current that comes directly from a specific coil on the stator. So if it was that type, that's what these dashed lines indicate. Here's our source coil running in to power it. Okay, let's pretend that instead of that it was a DC CDI, which meant it's powered from the battery. So here we have lines showing battery power running into the CDI box. Now you'd only have one or the other. I just drew these in dashed lines to show you one of these type of power sources is being used to power this guy. Okay, then we need a timing signal. We need to know where the motor's at in its rotation so we can calculate timing correctly and know when to fire the spark plug. Okay, well that's coming from our pickup coil or pulsar coil that's drawn right here, and that's being triggered by the timing trigger or the reluctor on the flywheel. And we know the flywheel is keyed to the crankshaft using a Woodruff key, so it's located correctly and the timing marks are synced up with the motor correctly. So when that flywheel is turning and the trigger is passing our pulsar coil has a little magnet inside of it, which I drew kind of in the center, and then it has a coil of fine wire wrapped around it. So that works basically just like a stator, except kind of the components are reversed. The magnet's not inside the flywheel, the magnet's actually in here with the coil wrapped around it, and we have a piece of metal passing past it. Well, that produces a positive and negative, or negative and positive pulse, depending on how this coil's wound, that is then fed into the CDI box. So here we have our pickup coil input coming into the CDI box. From there, the CDI box now knows where the motor's at in its rotation, and it can calculate the RPM because it knows how many degrees long this trigger is, and it knows how long it took to produce that pulse. So we have all that information, and then we know what the RPM the motor's turning at and where it's at in its revolution. Well, from there we can then calculate when to fire the ignition coil, which will then fire the spark plug. using our power source, either AC or DC depending, we're actually charging up a capacitor inside. A capacitor is kind of like a little battery that will store charge. So it's being recharged after each time it fires from its power source, AC or DC, and sitting there waiting until the electronics inside calculate the correct timing. When it knows when to fire, it then discharges that capacitor out to the ignition coil, which is why it's called CDI, capacitor discharge ignition. Okay, when that happens, we'll go over to our ignition coil. We then have current running through the primary of the ignition coil. That's the first set of windings inside the coil. This is basically a little transformer. And when that current runs through the primary, it'll then induce or cause current to flow in the secondary winding, which is a different number and size wire, a different ratio of windings to each other. This will then generate high voltage in the secondary winding, and this is all inside the ignition coil. Now we have a really high voltage coming out of our spark plug wire that will go out to the spark plug and actually produce the spark right there. Okay, so we know how all that works. The other thing I drew here is the kill switch wire. So we actually have some sort of wire going in that usually when grounded from your kill switch or your key switch on the handlebars will prevent spark. So that's how we turn the motor off, by usually grounding a wire. Sometimes opening the circuit, just depends on the bike. But that will then prevent the whole ignition system from running. Okay, so that's our ignition and charging systems. The other thing we want to show is our starting system with our starter relay. So if we have our battery over here, which is being charged through our charging system, we then have our start button that has power run to it and is sitting there waiting. When the start button is pushed, this switch will close and provide 12 volts or provide power to the starter relay. Well, and it might have another wire or it might be grounded, but that's running wire through a coil inside the starter relay. When that coil has current running through it, it'll then cause a switch to close inside. Well, that switch connects the two large terminals on the starter relay. One of those is permanently connected. I kind of drew this wrong. This should be connected to battery power. We'll connect battery power directly out to the starter motor, which then causes this guy to turn the motor over. So I hope that kind of gives you an overview of how all these different components work together. Now that you know what each piece is and what it does and how it works with the other pieces in the system, hopefully you'll have a better understanding of your bike and be more comfortable changing parts and repairing it yourself. So thanks for watching these videos. Make sure to check out RMSTATOR's website for more information and to learn how to troubleshoot these parts and fix it yourself. Hey, thanks for watching our videos. Make sure to like and subscribe to our videos so we can keep putting out more. And we'd love it if you'd leave comments on the videos and let us know what you guys want to see next. If you have questions about specific parts or how to test them, how to install them, or how to put some parts on a particular vehicle, make sure you let us know. We're happy to keep doing these videos and want to make sure that we produce what you guys want to see.